In this video, we will ask ourselves, what is a derivative? What is derivative? So let's begin by recalling that to find the slope of a line, we'll get its slope, right? So a slope is basically how steep a line is with respect to horizontal. So how do we measure the steepness of a line? So it can be measured by dividing getting the ratio of how much we rise with respect to how much we go from left to right. So for instance, here we have rise this much as we go from this point to this point. So we call this line here as the run, and here the rise. And we often denote the slope as m, and that's the rise over run. So the higher the slope is, the more steep our line would be, and the lower the slope, the less steep our line would be. For example, if we have a slope of 2/1, so for every unit we go to the left or to the right, from left to right, we go 2 units. So that's 2 as rise and 1 as run, and then 1 and then 2. And so if we connect this one similar to as we go on a ladder or on the stairs, we can see this one. On the other hand, if we choose slope that is less steeper than this, and here let's say we have a slope of 3/4, or what do you want? 3/4 would do, since denominator is bigger than the numerator. Then that literally means if we go 4 units to the right, we'll go 3 units upwards. 4 units to the right, 3 units upwards. So if we continue that, we'll get a line that is less steep than this, right? So that's how we measure the slope of a straight line. Now how about if we have a curve? How do we measure its slope? What would then be its slope specifically of this curve? To first approximate the curve by a secant line. Say this is our secant line here. All we know is we can measure the slope of the curve on a single point. So that's it, diba? On this point, we can say that this is the slope of the curve, specifically at this point. So unlike here on a line, it's pretty much easier, yes, because we'll get a constant if we go rise over run. But then on a curve, it's a different story, because on a curve, it has varying rise and run if we go from left to right, diba? For example, at this point, let's say from 0 to 1, say this is 1 here. We can see that at 0, it has a slope of something like this. Then as we go to 1, it changes from this one to this one. And so, for curve, its slope is changing for every point, diba? So that is why all we can do is make a tangent line to every point. So to do that, we can start by making a secant line and denoting that on this point where our tangent line intersects the curve, also this point. We said a while ago that slope of a line, so this line, the red line, is the rise over run, or how much we go upward with respect to how much we go from left to right. So just rise over run. Now how are we going to make this a tangent line? So by the idea of limits, as you can see, if we make this delta x becomes really small, right, then this delta y will also becomes really small, and as if it is very close to this point. So when that happens, you can see that it's becoming very near, or it's becoming close to a tangent line, diba? That's the idea of limit. It's more like, the analogy is if you divide if you split 10 into 2, let's say 10 divided by 2, you'll get 5. 5 divided by 2, you'll get 2.5. Divided by 2, you'll get a number. Divided by 2, and so on. If you continue to divide it, you won't reach a boundary or a finite point. You can just continue to divide it, but you're not actually making it 0, alright? That's the idea of this delta x. Just making it approach as if it has no length, as if we have no run here. So when that happens, we'll get a tangent line. So instead of using delta x on this point and this point, the change, you're gonna use x, and on this point, x plus h. Alright? For simplicity, you can see it later on. So that the delta x we have here a while ago, that delta x will be equal to h. So that length, delta x, is equal to h. Alright? So if we have, for example, here, if this point is 7 and this point is 10, then our h is 3. Alright? So this point is just 3 plus 7, so we get 10. So this 7 and 10. So to this, in order for this to become 10, we just add the x and h to get here. Now since this is a function of x, then if we have a point here, x, then this point here corresponding to this x is gonna be f of x. We're gonna literally insert this to the function. And for this one, since this is x plus h, if we insert that here, then we'll get f of x plus h. Right? And as we said, this one is the delta y. So to calculate the delta y, measure of delta y, we'll say that it is the final position minus the original. So our original position is f of x, and our final is f of x plus h. So we'll just subtract them. The final position, so x plus h, minus f of x, which is the original. And then for our run, so this is just the rise, and this is the run. Instead of saying delta x, we're gonna say that's only h. Right? So now it's more simpler. So just take note, this numerator refers to rise, and this denominator refers to run. And so now we already have the slope of the secant line. Slope of secant line. Now from this point, to make this slope here, again, to make this slope here become a tangent line in this point, we said a while ago that we should take this change in x approach 0. Alright? Let that delta x approach 0, or h approach 0, so that it will become tangent on this point. So now, the slope of tangent line is just equal to the limit as h approaches 0 of f of h. So this is now how we get every formula you've been memorizing, like the power rule, as for example x to the n, it will become close in quantity n minus 1 times the original function, say this one, x to the n, it will become n minus 1, then x to the n minus 1. Alright? So this formula right here literally came from this one. So on the other video, later on, we're gonna prove that that formula came from here. So let's try and learn more about this formula. This is the slope of the tangent line, and that is what a derivative is. So if we have a function, its notation is like that. F prime of x is just the limit as h approaches 0 of f of x plus h minus f of x over h. So how do we use this formula? So let's try if we have y equals x squared, or say f of x equals x squared. These are f of x and y are just equal. So if we have that, how are we going to find the slope of this curve? So that you can see it, the curve looks like this. It's like that. So as we say, every point of this has a tangent line. It's like that. And to use this formula right here, we'll just first fill this out. F of x plus h. So x plus h. So what is the function if we insert x plus h? So f of x plus h is equal to x plus h squared. Alright? We're just gonna insert this point because as you can see here, it's just a point. It's on x values, this one and this one. So we can insert that to our function. It's like that. To find what is our function. Here, it says it's just x. So just insert what happens f at x. So it's just f of x. So now plugging it to our formula, f prime of x will then become the limit as x approaches 0 of f of x plus h. So that's this one, x plus h squared, right, minus our f of x, which is just literally x squared. Alright, here you can see f of x. So our x, we're just gonna insert here in our function to have x squared. Right? So that's gonna be minus x squared all over h. So if we expand this one, we're gonna get x squared plus 2xh plus h squared minus x squared, this term, all over h. So you can see x squared minus x squared is 0. And if we factor out h, since h is common to these two terms, we're gonna get limit as x approaches, h dapat ni sila, h approaches 0 is going to be h 2x plus h squared all over h. And now we can cancel this h because h over h is 1. Although masinakaingon mo nga ang h, di ba, kuha na siya 0, we can't, dili ta pwede makadivide because h over 0 is dili pwede. No, because we let h only approaches 0, it becomes really close to 0 but not actually getting to 0. Masya idea, so we can cancel this. So that now we are allowed to cancel that. Alright. Wala na siya squared. Factor out na. So with that, if we apply limits on this one, we just substitute 0 to this. And so our f prime of x is equal to 2x. Thus, f of x, which is x squared, its f prime of x is equal to 2x. So this is what the derivative means. This is what a derivative is. It is the slope of a tangent line, or a line that is tangent to a curve. So this is the formula for the slope. Alright, 2x. So how are we going to find? So let's say at point 1, this point here. So the slope at this point, specifically at 2. So this is our formula. We'll just substitute 1. So our slope for this one at x equals 1 is 2. How about at x equals 10? Let's say, continue that dire, 10. So we just substitute 10 here. Then the slope at x equals 10 is 20. So this is what a derivative is. Thanks for watching.